Hey, it's Alex from cnc-o-rama, and this is my third video in a series of videos on G codes for a CNC mill. So let's look at what we already covered. So we went over G0, G1, G2, and G3, and let's see, we programmed this part basically in NC Viewer. This is our code on the left. But the parts were not, this code is not ready to like put in a CNC machine and run. There's a lot of stuff we have left off still. So let's look at some of those things. So some of these other codes here. So let's first look at these code groups. So I mentioned before, a code group is a group of codes where only one group or one code out of that group can be active at one time. So G0 and G1 will conflict with each other, so only one is active at any one time. And these are modal codes, so they stay active until they're replaced with another code from that group. And when you turn on the machine, generally one code from each of these groups is already active, and they will stay active until you replace them with another code in that group. There's also this group 0. So these codes are in the group 0 are the non-modal codes, and those need to be called on every line that you want them to occur. All right, so let's go through some of these. So dwell, basically you can stop the motion of your axes for a certain number of seconds, and these can be milliseconds. It can be a very short dwell, or it can be long dwell. But that's what that's going to do, and it's not going to stop the spindle generally. It might depend on your machine, but your spindle is probably going to still be going when you do a dwell. Okay, this next group of codes, G17, G18, and G19. So in the last video, we talked about arc movements with G2 and G3. And those arc movements were in the XY plane. If we look at this, everything here, all these arc movements are in an XY plane, and they can be at any Z level. They can be higher or lower, but they're going to be parallel to that XY plane for their motion. So there's also the option to do arcs in two other planes. So you got the G18 arcs are in your ZX plane, and then G19 arcs are in your YZ plane. I and K define the center on G18 arc. So you have I and J. So I correlates to the X axis, and J correlates to the Y axis in your arcs. You can look at how we did this to find the center point of that arc. If you're in another plane where you're using the Z-axis now, you would replace that with a K. So you're either doing an I and a K arc or a J and a K arc. So we'll get more into depth on those probably in another video, but just know they exist. And when you turn on the machine, the default should be G17. And that's probably what we'd use the vast majority of the time. But just if you see a G18 or a G19, you know that it's doing an arc in a different plane. And what's interesting is you can't, on most machines, you can't do an arc on some angled plane that's not in those three planes. If you do an arc like that, it'd probably be a combination of many G1 moves to simulate that arc. Okay, so this one's pretty self-explanatory. G20 means you're working in inches. G21 means you're working in millimeters. So now that we have these first few down, let's just go look at this program we already started. And I'm going to put in I'm going to kind of build it out more like a program you would see that you'd actually run. So in most programs, the first and last thing in the program is a percent symbol. And that just, I think that goes back to the old days of CNC when it would just store all these programs in the memory, and that's the only way it could tell when a program starts and ends with these percent symbols. I think the controllers today are much more sophisticated, and it's just a separate file. But it's still common to see the percent symbol at the start and the end. And then you have an O number. I'm going to do a capital O. I'm just going to call this 1, 2, 3, 4. So your O number is what identifies the program. So you can't have two of the same O number in the machine memory at the same time. So they're typically four-digit numbers, but sometimes there are others. And then I'm going to put a comment on here. I'll call it, let me just say, put on caps lock, cnc-o-rama part. So you can put a comment on any line of your program. If it's on this first line with the O number, that's generally going to show up in your directory on your CNC machine when that program is saved into the memory of the machine. So I like to put something in this first comment on the O number line that is really helpful for me to identify what that is. Okay. And usually after that we have a tool list. So that's also a comment. So we can say like T1, let me just do T1. 0.5 N mil. And sometimes there'll be other information in here. But it's just a comment just for the operator to be able to see what's going on with that tool. Okay. Another thing that's really common near the top of the program is what's called a safety line. So if you look at here, anything that we would want active at the start of the program just to reset everything to kind of the defaults. So for a mill, we probably want to have G17 active. If you're in the United States, you probably want G20 active. If you're anywhere else in the world, you probably want G21. So I'm going to do G17. You can also space this. G17, I'll do G20. Let's see what else we can put in there. We haven't talked about these codes yet, but this is a cancel thing. Anything that's canceling would be kind of helpful to have in there. So we can put G40. I might avoid G49 for now. G80 is canceling can cycles. G90 is absolute. So maybe we'll do G40, G80, and G90. So this is a pretty typical line of safety codes that you would see. Okay, so the group 14 is our user work coordinate position. So these are work offsets. So what this is doing is defining your work origin. And there's a setting called there's the work offsets page in your controller where you have to basically teach the machine where the origin is on your part. Maybe it's on the fixture, but the machine needs to know where that origin is That's all up to the operator to set up. So as a programmer, you can just pick one of these and say, I'm going to use G54 on this as my origin. So and G54 is the most common, so maybe we'll put a G54 up here. And we'll probably go over this more in detail in another program, but you can actually have multiple work offsets, multiple origins active on your table at the same time, and you can have your program jump between them and all this stuff. And then another reason to have different work origins is if you're sharing a machine and everybody's using G54, you can be like, I'm going to use G59 just to like have my own work set up over here that nobody else can, hopefully nobody else will mess with while I'm out for the day or whatever. Okay, and then let's see, I think that's kind of all we need from those G codes. We haven't looked at M codes yet, so there's some stuff up here that we should look at. So M3 is spindle clockwise, and we call that the normal direction because some people get confused depending on which direction you're looking at. The spindle clockwise can be reversed, so it's easier to think of M3 as just turning it on the normal direction. And it's very rare to have left-handed tools that actually are cutting the opposite direction where you would have an M4. So we basically use M3 for everything. There's always exemptions to everything, but I'm just going to. So we have M3. We know we're going to be turning on the spindle up, but we don't have a tool yet. So maybe we should grab a tool. So we put a comment up here that there's a tool one. So we can do M6T1. That is going to change to tool one. And in most machines, when you have an M6 code, wherever the spindle is, it's going to stop the spindle and it's going to return to where the tool change happens, and then it'll do the tool change. So there are multiple steps in that. That's if you have an automatic tool changer. Some people don't have an automatic tool changer, and usually in those machines, an M6 will just stop and wait for the operator to switch tools. Okay, so M6T1, we change to tool 1. And then usually after that, we want to turn the spindle on. So like I said, M3. And we don't have a spindle speed yet. So I'm just going to say S5000. So there's calculations on speeds and feeds. We'll get into that at another time. But the spindle, your speeds and feeds, speed is the spindle speed, RPM, depend on your cutter, the material you're cutting, your machine, and all these other things. So I'm just putting 5,000 in here as a placeholder. So the spindle's on. And it's okay to skip lines like this. So we're going to wrap it to this point. You know what's another thing that's really a good thing to do? We haven't talked about G53 yet. The G53 is one of the codes you can use to send an axis home. So G53 is actually your home position in your machine. So if I command a G53 Z0, on that line of code, since it's a non-modal code, it's only active for that one line, but for that one line, it's using our home position of our machine as the origin on this move. When I say G53 Z0, that's usually at the top of travel or near the top of travel. So why would I want to send it home? That's just another kind of safety thing. If the last person who operated the machine left the tool way down near the table, we don't want to have this rapid XY move that could collide with something on the table. We'd rather send it home and then move and then come down. And another thing I just remembered, depending on your machine, I know Haas wants a G0 with your G53. So not every machine needs a G0 with your G53, but Haas does if you're on a Haas. All right, what else do we need to do? Okay, so we move to our starting position. And we need to activate the tool length or the tool height. That's two words for the same thing. So if you think about your machine, every tool in there has a different length where the tooltip is in a different spot. And so to bring two different tools to Z0, the head of your machine is actually going to be at a different place. So you have to, the operator has to set up the machine so that it knows where that tooltip is. And then the programmer has to activate that tool height or tool length. And that's done with a G43 and then an H with the number that matches the tool number. So since I'm using tool 1, I'm going to use G43H1. And then it's pretty common to have a Z move on this same line of code. So maybe I'll go to Z1, so I'm above. So if we plot this, everything we've done isn't really changing our plot. I guess there's one extra line in there, or one extra point in there that we just added with this Z1. But all this stuff, as far as NC viewer goes, it's just kind of fluff. But it's actually very important to your machine once you are running a part. Okay, so we activated our tool height, came down, and I would probably make this a G1. So we rapid to this point, and then we're going to switch to a feed move here. And since we have two G1s in a row, I'm actually going to delete the second G1. All right, so we have a G1. The thing we didn't add in here before is we need a feed rate. So I'm going to say, again, I'm just putting a number in here as a placeholder, but I'm going to say feed 20 inches per minute. And that feed rate is going to carry through all of these. So any G1 uses a feed rate, G2 and G3 both use feed rate. So unless we change the feed rate on one of these lines of code, it's going to be the same all the way through. All right, and how we sent Z home up here, when we get to the end of our program, we're going to want to send Z home again. It's just the right way to do it. So we can say G0 again, G53, Z0. And then, assuming this is our entire program and this is the end, you usually want to bring the table closest to you, the operator, so you can unload the parts. So in that case, we want to send Y home, G53, Y0. And we could have sent Z and Y home on the same line of code, but it's typically better to send Z home all by itself. And the reason I think about that is my analogy is Imagine you're a helicopter pilot in New York City and you're flying across town. Probably the first thing you want to do when you start up your helicopter is go straight up. You don't want to go forward because there's all these buildings in the way. You want to go straight up, and then once you're above these buildings, you can fly to wherever you're going. And then once you get to where you're going, just go straight down. So that's what I like to do with Z. All right, so we've done that. So at this point, our spindle is still on, so we should probably do an M5. And actually, we could have put the M5 on another line. Like we could have put the M5 here when we retracted Z. So an M code can be on the same line with G codes. It can be on its own line. I always tell people, if you're approaching the part or if you're near the part, any chance that you could collide with the part, you usually do less damage if the spindle is spinning, because the end mill will just cut into the part as it's decelerating, and then rather than just having a hard collision. So I am always wary to think about where do we want the spindle on and off. So we could maybe put it down here on this line. Either one will work though. And then at the end, the last thing in your code is your M30. So that tells us, or tells the machine that we are at the end of the program, and it can rewind to the top and wait for us to hit cycle start again. Okay, so we didn't do our coolant codes, M8 and M9. So if we think about where we want our coolant codes, you definitely want the coolant on before you start cutting. I don't like to turn on the coolant too early, because if your spindle's way up high where your coolant nozzle is going to be, if you start spraying, it's going to get the whole window covered with coolant, which makes it harder to see what's going on. So maybe when we come, maybe on this line is where we want our M8. Oops. We turn on the coolant when we're already kind of down there close to the part. Sometimes coolant can take a few seconds to actually start running, so I wouldn't want to turn it on like on the same line where we actually make contact with the part. So coolant is on, and then same with coolant off. So we probably want to turn off coolant like here as we're sending Z home. Another thing with M codes, on most machines, it doesn't like two M codes on the same line. So even though it may be tempting to put an M5 and an M9 on the same line, that's not really standard for how we should do it. All right, so I think we covered all the stuff we kind of needed to fill in on this. There's definitely more that we can do, but this will give us the start to our program. So I'm going to end there, and we'll look at some other stuff and some more in another video. So there's still a handful of G codes and M codes we haven't covered.